Good morning. My name is Elizabeth Hutto, and today we are going to be talking about divergent plate boundaries. So, as a total disclaimer, I do not have a huge background steeped in science. So, what works for me is for someone to basically break things down as simply as possible in order for me to be able to understand them. So, we're going to do that in the beginning, and then we're going to get into a little more detail as we go. So, to start off with, what are divergent plate boundaries? So we know divergent plate boundaries are locations where tectonic plates are moving away from each other. I chose this graphic specifically, and we are going to get into that a little more. But essentially, what happens to bare bones and break it down is that at divergent plate boundaries, tectonic plates move away from each other and magma pushes up. So what happens at those points is the earthquakes are very common and magma rises from the Earth's mantle to the surface, solidifying to create new oceanic crust. Now there are two types of divergent plate boundaries. There's oceanic and continental. We're going to get into both of those. So the first one we're going to do is oceanic. When a divergent plate boundary occurs beneath oceanic lithosphere, the rising convection current below lifts the lithosphere, producing a mid-ocean ridge. Extensional forces stretch the lithosphere and produce a deep fissure. When the fissure opens, pressure is reduced on the mantle below, and it responds by melting, and the new magma flows into the fissure. The magma then solidifies, and the process repeats itself over and over. Effects that are found include a submarine mountain range, volcanic activity in the form of fissure eruptions, shallow earthquake activity, the creation of new seafloor, and a widening ocean basin. Now, for both of these, I tried to pick examples for very specific reasons. So, for this one, I picked the Mid Atlantic Ridge because it is the most well known, it is the most popular, and you can actually see I've circled the plate boundary right here in red, and this, where I've got my arrow, this blue line is actually that boundary line that is pushing those two plates away from each other. And again, this is called the Mid-Atlantic Ridge. The other type of divergent plate boundary is continental. So when a divergent plate boundary occurs beneath a thick continental plate, the pull apart is not vigorous enough to create a clean single break through the thick plate material. Here, the thick continental plate is arched upward from the convection current's lift, pulled thin by extensional forces, and fractured into a rift-shaped structure. As the two plates pull apart, normal faults develop on both sides of the rift, and the central blocks slide downward, causing earthquakes. Early in the rift forming process, streams and rivers will flow into the sinking rift valley to form a linear lake. As the rift grows deeper, it might drop below sea level, allowing ocean waters to flow in producing a narrow, shallow sea within the rift. The rift can then grow deeper and wider, and if it continues, a new ocean basin can be produced. So I chose for this one, I chose the Red Sea Rift. Now, if you Google, just for example, if you Google continental divergent plate boundaries, this is not the first one that pops up. However, I picked this one because it is the most developed. It is a fully developed continental divergent plate boundary. And if you look right here, you can see where these two tectonic plates push away from each other, creating this Red Sea right here. They've pushed away from each other, allowing the ocean water to come in and create this Red Sea with a new oceanic floor. And that is divergent plate boundaries.